In the final video for this 2x2 systems review, we will solve 2x2 systems by elimination. In this case, I think the easiest variable to eliminate is going to be x, and I can accomplish that by multiplying this equation by 3, and I'll bring it down here and get 12x minus 18y equals negative 16 times 30 times 3 is negative 48. And now I can combine these two equations, and these will cancel, and I get 9 minus 18, that's negative 9y, and 30 minus 48 is negative 18, and negative 18 divided by negative 9 is 2, so I get y is 2. And I can plug that back into any equation I want. I'll go with this top equation, 4x minus 6 times 2 equals negative 16. Negative 6 times 2 is negative 12, so if I add 12 to both sides, I'll cancel that out. 4x equals negative 4, and when I divide by 4, I get x equals negative 1. Okay, so the point of intersection should be negative 1, 2, and we'll check that. 4 times negative 1 minus 6 times 2 is negative 16, checks out in the first equation. Negative 12 times negative 1 plus 9 times 2 is 30, checks out in the second equation, so I know this is correct. And for this second one, let's eliminate the x's by multiplying by negative 2. So that gives me 6x plus 20y equals 8. And when I combine that with this top equation, the x's cancel, the y's cancel, and so do the constants. So I get 0 equals 0. And that is a true statement, which means there's an infinite number of solutions. That does not mean every point in the world is a solution. What that means is if I was to graph like I did up here, I would get one line that lies right on top of the other. So along the line, every point, whether it's integer or decimal, would be a solution, and there's an infinite number of those points. So when we get a true statement like this, that means there is an infinite number of solutions.